Alright, up next we'll be looking at types of probability. The first type of probability I want us to look at is the probability known as one probability. One probability. What do we mean by one probability? Before I define this one probability, I want to take us back to the formula for of probability. Now, the probability of any events occurring is the number of such events that we are looking at probability all over the total number of possible events, right? Now, this makes every standard probability a fraction. So, for every standard probability, you are always expected to have a fraction, and this fraction must be a proper fraction. If at any point in time you solve your questions under probability and you get an improper fraction, just know that your answer is wrong. You are expected to have a proper fraction, and I believe you all know what a proper fraction is. And in case you don't know or you have forgotten, we'll drop the link to where we treated fractions on the video. So you just click on the link and get yourself equipped in proper fraction. So we say that if the probability of an event occurring is 1, it means that that event is certain or sure to occur. If the probability of any event occurring is 1, it means that that event is 100% certain to occur. And what are examples of such events? Now, one good example of such events is having a night. Having a night. It is 100% certain that in 24 hours you must have a night. So the probability of a night occurring within 24 hours is 1. And the probability of having a day within 24 hours is also 1. So such events, of which its occurrence is 100% certain, is known as what? 1 probability. And their probability, because the answer to their probability is just 1. Alright, the second type of probability I want us to look at is the zero probability. Now, what do we mean by zero probability? Just like we introduced in under one probability, our standard probability solution is supposed to be a fraction, a proper fraction at that. But if two events, or if an event is said to have a zero probability, it means that that event can never occur. Events with zero probability are events that can never occur. And examples is a man getting pregnant. A woman can never get a man pregnant. A man can never get a man pregnant. So there is no way a man can get pregnant. Another example is a woman impregnating her fellow woman. It is not possible. So the probability of such events occurring is 0, 0. Our next type of probability is what we refer to as multiplicative probability. What is multiplicative probability, and when do you use multiplicative probability? We use multiplicative probability when we require to find probability of 2 or more events that occurred within a sequence. Now get the jig. We use multiplicative probability when we need to find probability of 2 or more events that occurred within a sequence. And you know what I mean by sequence? One after the other. Now let's say that probability of event A to occur is 1/3, and the probability of event B to occur is 1/5, right? So the probability of picking of event A and event B is equal to, the solution is probability of event A times probability of event B. So our probability of event A is 1/3, and probability of event B is 1/5, which is equal to 1/15. So we have the probability of event A, or probability of having event A and event B is equal to 1/15. So the key word in multiplicative probability is and. The key word in multiplicative probability is and. So if you have, so we use this simply means that we use multiplication to solve a probability question. Here you have and. Alright, and let's look at this example under multiplicative probability. Now it says, in a bag containing 2 blue balls, 3 green balls, and 1 black ball, what is the probability of picking a blue ball and a black ball? So our solution, we're looking for the probability of picking a blue ball, right? And probability of picking a black ball. Now this and in this question carries heavy weight. But before we make use of this and, we need to find probability of picking a blue ball and also probability of picking a black ball. Remember what we said about probability. Formula for the probability of any event occurring is the number of that event. Sorry? Number of that event all over my sample space or total number of possible events. So for our blue ball, so probability of blue ball will be equal to number of blue balls all over total number of balls inclusive, right? So how many blue balls do we have? We have 2 blue balls. So we have number of blue balls, which is 2, all over total number of balls, which is we have 2 blue balls, 3 green balls, and 1 black ball, which is 2, 3, 1, which is 6. So we have 2 over 6, which is equal to 1 all over 3. Now this is the probability of picking a blue ball. Remember, we'll also need to find probability of picking a black ball. So probability of black ball is equal to number of black balls all over total number of balls available, right? Now, how many black balls do we have? We have just 1 black ball, which is equal to 1. All over total number of balls is 2, 5, 6. All over 6 balls. So we have the probability of picking a blue ball is 1 over 3. And probability of picking a black ball is 1 over 6. But the question is asking us for the probability of picking a blue ball and a black ball. Now remember, the picking did not occur at the same time. 1 ball was picked after the other, okay? So we have under multiplicative probability. Remember what we said. We use multiplicative probability when the word and comes into the question. So probability of blue and black is equal to, this is my blue, and we say that and goes with multiplication. So we have probability of blue and black is equal to 1 over 3 and 1 over 6, which is equal to 1 over 3 times 1 over 6, which is equal to 1 all over 18. So the probability of picking a blue ball and the probability of picking a black ball is equal to 1 over 18. Now this kind of question is what you know falls under the multiplicative probability kind of questions. Now, but this question can come in various forms. Like this question can come in various forms. Remember what you said? The blue ball and the black ball was not picked at the same time. It's either the blue ball was picked first, then the black ball was picked, or the black ball was picked and the blue ball was picked. Though in probability we assume that the color or the event that comes first was the one that occurred first. So it is assumed that the blue ball was picked before the black ball was picked. Now, but there is a logic behind this kind of question. Now, imagine I have 1, 2, 5, 6. I have 6 balls in a bag, right? Now, initially from the question, we had 6 balls in a bag. Just that we had 2 were blue, 3 were green, and 1 was black. Now, imagine in such situations, if I pick a ball firstly, and the color I picked is blue, right? Now that one I picked, after picking, it is expected or it is assumed that I remove the ball I picked before I pick the second one. Now, in the second instance, I will no longer have 6 complete balls because I've already removed one, right? So it means that if I should remove my first pick, I will have 1 pick left. Now, that is why I said this kind of question can come in 2 forms. Now, but the good thing is that you will be specified on the pattern that you use to solve the question. Now, if after the first pick, whatever was picked was separated, you will be told in the question. You will be told in the question. And how can you be told in the question? Now, the question will come in this form. You must be told that the balls were picked without replacement. The first solution I used, okay, I solved it assuming that there was replacement. What do I mean by assuming that there was replacement? I assumed that after the first blue ball was picked, like it's an experiment. So after they put my hand into, or whomsoever it is, after the person dipped his hand into the bag to pick a blue ball, he dropped it back, then dipped his hand again into the bag to pick another ball. Now that was the situation or the scenario of the first solution we solved. Now, but in cases whereby you have questions without replacement, now this is actually telling you that after your first pick, whatever result or whatever event you got after your first pick was kept aside before the second pick. So the solution to this kind of question is, they say, the probability of picking a blue ball and a black ball. So we assume that the blue ball was picked first. So we have probability of picking blue ball. Just like we said, we have 2 blue balls all over, total number of 6 balls, which is equal to 1 all over 3. Now, but when it comes to probability of picking a black ball, in this question, you were told that it is without replacement. So what does that mean? It means that the first blue ball that was picked was not replaced. So during my second occurrence, or during my second pick, we have how many? We have 1 black ball all over. 1 blue ball is already missing from the 2 blue balls. So I will now have 1 black ball, 3 green balls, and 1 remaining blue balls. So my total number of possible occurrences of my sample space here will now become 5 instead of 6. Will now become 5 instead of 6. Alright? So the probability of picking a blue ball and a black ball, remember our hand is still multiplication. So probability of blue and black will now become, this is 1 over 3 and 1 over 5, which is equal to 1 over 3 times 1 over 5, which is equal to 1 over 15. Alright? So this is still under multiplicative probability. Now, one key thing I will need you to know about this multiplicative probability is you use multiplicative probability when your question carries and. When your question carries and. Okay? And just like I tried explaining, such questions, they come with and without replacement. When there is replacement, the question, they wouldn't bother to include it in the question. You just, wherever you don't see without replacement, you assume that there was replacement after our very first experiment, after our very first pick. Alright? So you solve it using our first pattern. But wherever you see without replacement, it means that whatever is gone is gone. So you solve using this second pattern. Now that is it for multiplicative probability. Up next will be additive probability. And just like we said under multiplicative probability, the determining factor whether a question is additive is when there is an or in the question. Is when there is an or in the question. And additive probability occurs where you have mutually exclusive events. Mutually exclusive events. Remember I said that the events that cannot occur simultaneously at the same time. Okay? Or where one event totally eliminates, or where the occurrence of one event totally eliminates the occurrence of the other events. Alright, let's look at one or two questions under that. Alright, let's look at this question under additive probability. We have, if the probability of picking a blind boy from a community is 1/8, and probability of picking a blind girl is 1/12, find the probability of picking a blind boy or blind girl from the community. Now, in questions like this, how do you determine, the type of probability that this falls in, or this falls under? Remember what I said? Once or is the joining word, it is additive probability. So we have or here, and it is this or that gives us the solution to the question, or that gives us the direction to the solution to the question. So we have our solution. So the probability of picking a blind boy or a blind girl is equal to the probability of blind boy plus the probability of blind girl. Okay? And this is equal to probability of a blind boy, according to the question, is 1/8 plus probability of blind girl is 1/12. I have LCM of 8 and 12, sorry, to be 24. This will give us 3 plus 2 equal to 5 over 24. Alright, so we have that the probability of picking a blind boy or a blind girl from the community is 5/24. So, just like we said, additive, if you use you apply additive probability if your joining word is or, and you apply multiplicative probability if your joining word is and. Alright, these are the types of probability we have. But these types of probability can also be classified as the law of probability. These types of probability can also be classified as the law of probability, starting from our one type or one probability is a law in probability, our zero probability is a law in probability, our multiplicative probability is a law in probability, our additive probability is a law in probability. Alright, the fifth law I would like us to look at, or type of probability I would like us to look at, it tells us that if the probability of an event occurring is PA, then the probability of that event not occurring is 1 minus probability of the event occurring. So let's look at an example. Alright, an example is if the probability of picking a blue ball from a bag is 5/7, find the probability of not picking a blue ball. And from this our last law, or our last type of probability, it says that the probability of not picking a blue ball should be equal to what? 1 minus the probability of picking a blue ball. So our solution is very simple. Our solution is 1 minus 5/7, which is equal to 2/7. So the probability of not picking a blue ball, probability of not blue ball is equal to 2/7, and vice versa.